Welcome back to Mastering C++ 20 Features. In the last lecture, we looked at the rules for overload resolution of generic functions with template parameters, and later looked at simple requirements and nested requirements, and finally fixed the calls to add one functions by changing the constraint on numeric and pointer type from simple requirements to nested requirements. In this lecture, we will look at the details of compound requirements. You can also check the CPP reference page on compound requirements, but I have summarized the important points with examples in this lecture. Compound requirements are used to impose restrictions on return type of expression, and for this reason, the expression of the requirement has to be enclosed in curly braces, and return type is followed after the expression in a similar manner to the trailing return type that is available to functions and methods in C++11. The only restriction on requirement checking on return type is that it has to be validated against an existing concept, and therefore we cannot just use any compile time Boolean expression or a trailing return type expression. Here are some examples in the slide. You can come back and look at them later, but for now let's see some live coding examples. This is the same code as from the previous lecture. I promise that I'll show a variation on compound requirements in the next lecture and not drag this example anymore after this session. In the constraint for numeric type, I can add some compound requirements. For example, I can say that the expression param plus 1 should be valid. For this, I type the expression param plus 1 and semicolon in the end. But to enforce the requirement that the result of the expression param plus 1 must have the same type as that of param, I have to enclose the expression in the curly braces and then apply the requirement on the return type using the style of trailing return type by using this arrow and then using a concept called std same as. And in the template parameter, I can say decal type param. So here this entire expression says that param plus 1 is a valid expression and the return type of param plus 1 must be the same as that of param. I can enforce similar requirement by using a different concept also available in the standard, which is called std convertible to. This is different than std same as because, as the name suggests, std same as implies that the type of return value of param must have the same type as that of param. But in the case of std convertible to, it implies that the type of return value of param plus 1 can be something that is converted to the type of param. I can enforce another compound requirement here such that param is streamable or param plus 1 is streamable. Std cout param plus 1 and then enforce the requirement on the return type std same as std ostream ampersand, and this requirement specifies that the result of param plus 1 should be streamable. If I compile the code here, oops, there's a typo, param. Now it works fine as in the previous cases. For example, just to show you, this is not some dummy requirement. If I remove the ampersand from the last requirement in numeric type, I get compilation error. And similarly, if I say here, it is bool, let's see what happens. It works. But let's say, I don't know, std vector of type t or of type int. I again get a compilation error just to confirm that these requirements are actually working. Let me change it back. Param. Alright, I can similarly enforce another requirement here in the pointer type, namely param is comparable to null pointer and the result is convertible to bool, or the result is same as bool or convertible to bool. Forgot to add std here. And forgot to add also semicolon. Here in the second file, I have some more complex examples that I will demonstrate in the next lecture. And here also I'll show how to use the compound requirements. So stay tuned and enjoy learning modern C++. See you in the next lecture. Hello there. If you enjoyed watching this video, don't forget to hit the like button and subscribe to my YouTube channel. If you have any questions or if you would like to start a discussion on the topic covered in this lecture, please feel free to leave a comment on this video. And lastly, if you are interested to learn more about my courses, then log on to my course website, mastering-modern-cpp-features.thinkific.com. Thank you.